Okay, in this video we're looking at Newton's equations of motion, but known to most people as Suvat, a nice topic in maths. So let's kind of get into what Suvat is all about. What is this thing called Suvat? Well, before we kind of get into throwing you the equations and all of that stuff, let's go through a scenario. So right, imagine you're driving to school and there is your lovely car. Okay, in your car, you're going to travel some distance in a certain amount of time. So you've got distance you're going to travel in a certain amount of time. Okay. Do you know how you would find your average speed using distance and time? Perhaps you do or you don't. You might be aware of it, but to find your average speed, you may be aware of the formula that speed is equal to distance over time. You may not also be aware of that because that is also grade 5, but later on in the playlist. But maybe you've heard about it in physics or somewhere else. So average speed, so how fast you go on average, is distance over time. Brilliant. But we know in reality that the car speed, is changing all the time, as we're about to consider. You don't literally just, so let's say you're traveling from London to Sheffield, okay? Well, you're not going to be traveling at exactly the same speed throughout, okay? In reality, we accelerate, we slow down, we get faster, we stop, all of that kind of stuff, okay? So that's going to kind of get us onto our next part. And just note, we refer to velocity instead of speed. So just for the time being, take velocity to mean speed. They're slightly different. Okay, velocity has direction as well as speed, but just for the time being, just take velocity just to really mean the same thing as speed for the time being, even though there is a slight difference in their meanings. Okay, so we're just saying, right, in reality, we have things like, you stop, you change speed, you accelerate, you slow down, you go faster. So let's look at another scenario now. So now imagine your car starts at an initial velocity. That just means at an initial speed, and it ends up at a final velocity, at a final speed. So we're just saying it's velocity for the time being. Just think about it as being speed. So you start off at initial speed and you finish off at a final speed. And we denote initial velocity to have the letter u. So initial velocity, initial speed, okay, has the letter u. And we're starting off at 10. This means meters per second. That literally means meters per second. Okay, so actually 10 meters per second is pretty much what Usain Bolt ran the 100 meters at. Actually a little bit faster. He is covering 10 meters in 1 second. And then the car, it reaches a final speed, okay, which we denote by using the letter V of 20 meters per second. So 10 meters per second to 20 meters per second. Okay. The car must have traveled some distance, which we refer to in Suvat as displacement. Again, right, just think about displacement as meaning it's different, but just think about it for the time being as being a little bit like distance. There is a difference, okay, but for this video, you just need to think about it as being distance. That is fine. So like velocity, we think about it as being speed. Displacement, think about it as being distance. There are differences, but that's a different video. And the car, it might have traveled some displacement, some distance of 100 meters. Brilliant. The car must have also accelerated, which we use the letter A to represent that, in a certain amount of time, which we use the letter T to cover the distance. So actually, right, in this scenario, we've got a lot more things going on. Okay, we've got an initial velocity, initial speed. We had a final velocity, a final speed, which meant it traveled some distance or some displacement, S, and it must have accelerated to get from 10 meters per second to 20 meters per second over a period of time. So we can see, okay, we have 5 components of Newton's equation of motion. Okay, we had S, U, V, A, and T, and this is Suvat, okay, where the letters S, it represents displacement, which again you can think about meaning distance. Okay, it is slightly different, but just for the time being, just think about it as being distance for the time being. We saw U was the initial velocity, okay, and the standard unit for initial velocity is meters per second, which you can write like this. They mean exactly the same thing. That means meters per second, and so does that. The V, it represents final velocity or final speed. Okay, so velocity, again, thinking about it as meaning speed, a bit different, but yeah. And again, it's in the same unit because it's still velocity, meters per second. Also written like this, that is fine. We saw that A was acceleration. Acceleration is written as meters per second squared. Oh, that is wrong. That should be to the minus 2. So acceleration is meters per second squared, which you can also write as meters per second to the minus 2, like this. And we saw that t is equal to time. So often the issue with this topic is students, they don't really understand what all of those letters mean. They just think Suvat, okay, it's a bunch of random stuff. But we've sort of seen, right, where this stuff is coming from. So we've got SUVAT, Suvat, with these meanings you can see here. So I would definitely make a note of this stuff if you need to. So there are then some equations of motion, or just equations linking the variables S, U, V, A, and T that you'll be given in the exam, okay, but you need to be familiar with, because perhaps at first they do look a little bit intimidating, but it is nothing to be scared of. You will see this topic is basically just substitution, okay? Anyway, these are the equations you might see linking all of your variables, S, U, V, A, and T. So you've got V equals U plus AT, S is UT plus half AT squared, V squared is U squared plus 2AS. You can see them there. There they all are. I'm not going to read them all out. Don't be put off by this. You will be given these formulas, these equations, these formulas, in the questions. Okay, that is brilliant. So let's go back to our original example. Let's just say, right, we were given the initial velocity. Sorry, I also, if you need to, I would make a note of those equations. Okay, again, you'll be given them, but it's just useful just to kind of be familiar with them. So it's not a big jump when you do see them. So back to the car example, let's just say this time, right, we were given everything, the initial velocity, initial speed, the acceleration, the final velocity, and we wanted to go and find the time, okay? So we're not given the displacement this time. I took that out, okay, because we don't actually need it to find the time. We want to find the time taken to accelerate from 10 meters per second to 20 meters per second. Oh, sorry, let me just turn that off. So what you need to be able to do is you need to be able to choose a formula that has U, A, V, and then it has also T in it. So let's go and look at our equations. So, right, we need something with U, A, with V, and with T. So if we look at the first one, right, is there a V? Yes, there is, so that's good. Is there a U? Yes, there is, so that is good. Is there an A? Yes, there is, so that is good. And is there a T? Yes, there is, so that is really good. So actually, right, in this one, the first equation, V equals U plus AT, is good because it's got all of the variables that I have in the question, which means I can find the missing one, which is T. So Suvat at GCSE is pretty much a case of choosing your equation and then substitution. So let's do that. So we're using the equation V is equal to U plus AT, and then we just go and substitute in our variables. So V is equal to 20, and the units at this level, you don't even need to be able to really understand them, you just need your number part. So the V is equal to 20. So 20, with our substituting in our letters, is equal to your U, your initial velocity U is equal to 10, so 10 plus the acceleration A is equal to 2 meters per second, but just put the 2 in there, 2, and AT means A times T. So you're timesing 2 with T. T is what you are trying to find, so 2T. That is let's write that a little bit neater. This is the thing you're trying to find. And then it's just a case of rearranging to find your missing variable T. So balancing equations, solving equations, we're trying to find the variable T. We can go and take away 10 from both sides, take away 10, which is good because then these two cancel, these cancel, and these cancel. Sorry, these don't cancel. We've got 20. 20 take away 10, which is equal to 10, is equal to, the 10s go, we've got 2t left over here. And then 2 times what is equal to 10, or t must be equal to 5. So your time is going to be equal to 5. And a unit for time, okay, they will give it to you in a question, but it is seconds. So the time taken to accelerate from 10 meters per second to 20 meters per second is 5 seconds. So Suvat is a case of basically substitution at the GCSE level. Okay, fantastic. What we'll do now is we'll go through 3 examples, increasing in difficulty, okay, because the first one, they give you the formula and you're just finding the first letter. You then get a slightly trickier one where you've got to choose the formula and then a wordy question at the end. So we'll go through 3 examples and then 3 your turns, and that is going to be it for this video. But if you understand this stuff, you've got the topic of Suvat, which is fantastic. So this first one, right, it gives you the equation you need to use. So that could be the case most definitely. So it gives you that V is equal to U plus AT. and it says calculate V. So we're trying to find V when U is 10, A is 2, and T is equal to 4. So they don't even give you the units in this question. It's just literally a case of substituting into the formula. So we're saying that V is equal to, using my formula, U is equal to 10. So 10 plus my AT, A is equal to 2. So I've got 2, and AT means A times T. My value of T is equal to 4. So 2 times 4. Remember, in maths, if you're timesing things together, you can use a bracket. It's a good thing to do. So V is equal to 10 plus 2 times 4 is equal to 8. Therefore, my velocity, my final velocity, which is V, okay, V is equal to 10 plus 8, which is equal to 18. And in this question, there's no units being involved in this question, so I can just leave it as 18, okay? So V, which stands for my final velocity, is equal to 18. There we go. And that is my first example. So just literally a case of putting it into my formula, substituting into my formula. Question 2, it says choosing an appropriate formula. So you've actually got to go over to these over here and use the correct formula to work out the value of U when V is 70, A is 5, and T is equal to 10. So what you need to do, particularly in the early stages, you go through all of your formulas and you see which one is going to work. So the first one, is there a V? Yes, there is. Is there a U? Yeah, we're trying to find U. Is there an A? Yes, there is. And there's a T. Good. So actually, it's the first formula we're using. Again, we've got a V, U, A, and a T, which is nice. So it is the first formula. So we can go and write this down. So we're using V is equal to U plus AT again. Okay. And we go and put in our missing variables. So what's V equal to? V is 70. So 70 is equal to U. That's what we're trying to find. So leave it as U. Plus my AT. A is equal to 5. My time is equal to 10. I'm timesing it, so I write it in brackets like this. So just sort of simplifying out, 70 is equal to U. 5 times by 10 is equal to 50. So plus 50. This is an equation where I'm trying to find my missing variable U. I want to get rid of that 50 by taking away 50 from both sides. So take away 50 and take away 50. And then these 50s cancel, which is really good. And I've got 70 take away 50, which is 20, is equal to U. So U is equal to 20, which I can go and write like this. U is equal to 220. And that is my answer. So this time I had to sort of pick a formula, which happens to be the first one again. I put in my missing values, I substituted them in, and I rearranged to go and find U. So that is really good. Next one, a little bit trickier. We've got to understand the question here. It says a particle is accelerated uniformly from rest. Right, this just means a particle is accelerating at the same rate from rest. And that is a really key word that you need to be able to recognize. If you are going from rest, that means your initial speed, your initial velocity is going to be 0. Rest means you're stationary. And we know that U means initial speed, initial velocity. So initial velocity is U. So we can go and say that U is equal to 0. Okay. So that's after 10 seconds. So it's recognizing that 10 seconds is your time there. So your time T is going to be equal to 10. It has achieved a speed of 15 meters per second. So it's saying we've gone from rest. Your initial velocity is 0. And it achieved a speed of 15 meters per second. So a final speed, or a final velocity. So remember, V is your final velocity of 15 meters per second. Remember, V is your final velocity or final speed. It says find the acceleration of the particle. Okay, so let's go and get that. So find the acceleration. So this time we're trying to find the missing letter, which is A again. That's what we're trying to find. There we go. So this time, right, we've got 4 things, U, T, V, and A. And again, you go over to your formulas, and it happens to be the case. Again, sorry, I should choose and mix it up a little bit, but it is the way it is. I've got U, T, V, and A, which is the first one. I've got V, I've got U, I've got A, and I've got T. So again, I'm using my formula. V is equal to U plus AT. You then substitute, and then you go from there. So my V is 15. So 15 is equal to my U, which is 0, plus my A, and then I've got my my t, which is equal to 10. So 10 goes in there. So right, that 0, I can just kind of simplify it. So 15 is equal to 0 just goes, and I've got a times by 10, which I can go and write as 10, 10, 8. They mean the same thing. It's just better to write the number part first. I'm trying to find the acceleration a. I've got 10 times a. I've got to divide both sides by 10 to get rid of that 10. Okay, just solving my equation. The 10s cancel, which is really good. I'm left over with just the a. So a being equal to 15 divided by 10, which is equal to 1.5. So a is equal to 1.5, which I can write a little bit nicer like this. And that is my answer. My acceleration is equal to 1.5, written a little bit more neatly. Okay, brilliant. So what you can go and do now is you can try these 3 examples yourself. Hopefully the formulas will change this time. I can see they have changed, so that is really good. So you can pause the video and let's go through these ones. Okay, hopefully you've had a go at those and let's have a look at them. So the first one, it says calculate V when U is 8, A is 3, and S is equal to 6. So this one is easier because they give you the formula that you want to use. In this case, V squared is U squared plus 2AS. You substitute and you go from there. So we're trying to find V. So we've got, using our formula, we've got V squared is equal to U squared, well, U is 8, so we're doing 8, and then we are squaring it plus 2 times A. A is equal to 3. We're just substituting our value, so A is 3, and my value of S is equal to 6. So 6 goes into here. So V squared is equal to 8 squared. 8 times 8 is 64. I've then got plus 2 times 3 times 6. 2 times 3 is 6. Times by 6 is 36. So V squared is equal to 64 to 36 is equal to 100. So to get V, I've got to go and square root both sides. So V is going to be equal to the square root of 100. Okay, it could be plus or minus, but in this case, we're just looking at a speed here or velocity. We'll just hit the positive for the time being. Root 100 is equal to 10. So that is your answer. 10 is your answer. V is equal to 210. Perfect. The second one, choosing an appropriate formula, work out the value of t when U is 14, V is 26, and S is equal to 240. Okay, brilliant. So get t, U is 14, V is 26, and S is equal to 240. So you go with your formulas and you choose which one has got all of those. So the first one, is there a V? There is. Good. Is there a U? Good. Is there an A? Unfortunately, there is no A this time, so I cannot use the first formula. So I go to my next one. I've got S equals UT plus half AT squared. Is there an S? Yes, there is. Is there a U? There is. 14. Is there a T? We're trying to find T, so good. Is there an A? No, there's not. So we move on to another formula. Is there a V? Yes, there is. V is 26. Is there a U? 14. Yes, there is. Is there an A? No. And is there an S? No. So we move on to another one. Is there an S? Yes. Is there a U? Yeah. Is there a V? Yes. Is there a T? Good. So this time our formula is this one, okay, which is S is equal to U plus V all times by T divided by 2. So definitely let's make a note of this. We're saying our formula is S is equal to U plus V. We're timesing through by T and we are dividing through by 2. And then it's just a case of substituting in your variables. So S is 240, so 240 is equal to U plus V, and it is in a bracket, so U is 14. We're plussing on that V, which is 26. We're timesing through by T. Okay, T is what we're trying to find, so let's leave that there. And we're dividing through by that 2. And let's just go and simplify the bracket part. So we've got 240 is equal to 14 and 26 is equal to 40. So we've got 40. We're timesing it through by that T, and we're dividing by 2. So 240 is equal to 40 divided by 2 is 20. So we've got 20, and then we've got that T there. To get T on its own, we've got 20 times T. Let's go and divide both sides by 20. Divide by 20 and divide by 20, because then what happens there? These cancel, which is really good. And you're left with T being equal to 240 divided by 20, which is equal to 212. 240 divided by 20 is equal to, 240 divided by 20 is equal to 12. So good. T is equal to 12. Okay, so we can write it T is equal to 12. that is your answer. If you got that, really, really good. Okay, fantastic. It's just a case of really choosing your formula and then just substituting in your values. The last one, we've got a particle is accelerated from 1 meters per second to 5 meters per second. So this is saying, okay, your initial speed is 1 to your final speed being 5. So we just need to be able to know that, again, right, u, it is your initial speed or your initial velocity, okay, what you start off at, and then v, it is your final velocity or your final speed, what you finish at. So we accelerate from 1 meter per second, that's saying your initial speed, you need to know that u is equal to 1 meter per second, and then your final speed, v, is equal to 5 meters per second over a distance of 15 meters. So it's just, again, recognizing that your distance, okay, is like your displacement, which was that letter S. So remember S, we've written it down from earlier. S is your displacement, which we thought about as being your distance. Okay, so S is going to be equal to 15. And it says find the acceleration. Okay, so we want to go and find the acceleration over of the particle. So we go through our formulas to see which one we're going to be using. So we've got U, V, S, and A. This time, if we went through them all, okay, is it the first one? No. Is it the second one? No. It's going to be the third one because we've got a V, which is good. V is 5. We've got a U, U is 1. We've got an A, which is what we're trying to find, which is good. We've got an S, which is there. So it is going to be the third one. Good. So definitely I recommend you write down your formula again, which is this time V squared is equal to U squared plus 2AS. And it's just a case of you substituting in your variables into your equation. So V is equal to 5, but it's V squared. So it's going to be 5 squared is equal to U squared, or U is 1. So it's going to be 1 squared plus 2 times my A value, which is what I'm trying to find. So A times by my S value, which is equal to 15. And apologies, it's getting a little bit cramped, but hopefully you can see that. 5 squared, 5 times by 5 is equal to 25, being equal to 1 squared. 1 times 1 is 1. We've then got plus 2 times A times 15, or 2 times 15 is equal to 30. So 30, timesing it through by that A, and there we go. We're trying to find the missing letter A. We've got 25 is equal to 1 plus 30A. Well, to find A, we can begin by subtracting 1 from both sides. We are solving the equation here, so these ones are going to cancel, which is really good. We've got 25 take away 1, which is equal to 24, being equal to 30 times by A. 30 times A, to get rid of that 30, we can divide both sides by 30, because the opposite of timesing by 30 is to divide by 30, which means that these guys cancel, which is really good. And you're left with A being equal to 24 divided by 30. Well, you could use a calculator here, but what goes into 24 and 30 is 6. So you can divide the top and bottom here by 6, divide through by 6, divide through by 6. So 24 divided by 6 is equal to 4. 30 divided by 6 is 5. So A is equal to 4/5. Okay. So we've got A is equal to 4 over 5. As a decimal, 4/5 is equal to 0.8. So either, okay, as a fraction, 4 over 5 is absolutely fine. Or as a decimal, you get 0.8. Either of those is absolutely correct. Okay, a bit of a longer video, but hopefully you got a really good understanding to what Suvat is all about. Okay, thank you for watching. Brilliant.